Hello students, under the topic evaluation of inverse Laplace transform using partial fractions, here we have problem 3. Already we have completed problem 1 and 2, so kindly go through that to understand problem 3 better. Now in order to solve this problem, first of all we have to evaluate whatever is given inside the bracket. We have to separate it into fractions by using partial fraction. So how shall we do that? First we will write whatever is there inside the bracket. Now we will separate the denominators into fractions, where first this term is a simple term. So we can write a divided by s minus 2 plus, now here the next term is s square plus 1. If it is of degree 1, then if it is s plus 1, easily we can write b by s plus 1. But here the degree is 2. So whenever you have a square term, then you have to write it as bs plus c. This is by using the concept of partial fraction, which you would have already learnt in your previous classes, like when you were in first year. Okay, so now s square plus 1 has to be written as bs plus c divided by s squared plus 1. This is how you split up the terms when you have square in the term that has to be written into fraction. So remember this. So let me mark this as 1, so that after finding the value of a, b and c, we can substitute here. Now we have to take LCM on right side as usual, like how we were doing before. So on the right, what you will be having, a multiplied with, so in the denominator you will have s minus 2 multiplied with s squared plus 1. So a has to be multiplied with s squared plus 1 plus bs plus c has to be multiplied with s minus 2. And on the left you have s plus 2 divided by s squared plus 1 multiplied with s minus 2. So now if you see, this s minus 2 and s minus 2 will get cancelled, and s squared plus 1 and s squared plus 1 also gets cancelled, and we will have s plus 2 is equal to a multiplied with s squared plus 1 plus bs plus c multiplied with s minus 2. Now we have to give values for s in order that we can find the values of a, b and c. Now for that, first we shall make this term 0, so that we have to find the value of a. If we substitute, if we put s is equal to 2, 2 minus 2 will become 0. So this term will completely become 0. So we will put s is equal to 2. So what will be the left hand side? 2 plus 2 is 4 is equal to, the right hand side will be a multiplied with 2 square. So which will be 4. 4 plus 1 is 5. And then this term becomes 0. So therefore from this we get the value of a to be equal to 4 divided by 5. So this is the value of a that we have obtained. Next we have to obtain the value of b or c. So let me find the value of c first, because we have s over here, so that if we put s as 0, this term will easily vanish, and we have already found the value of a. So if we substitute that, we will easily get the value of c. So for that we will put s is equal to 0. So if we put s as 0 on the left, 0 plus 2 you will have, so it will be 2, which is equal to a multiplied with s square, 0 here you have. So 0 plus 1, which will be 1, plus here you will have b multiplied with 0, so that will be 0 only, and so you will be left out with c alone, multiplied with 0 minus 2, which is minus 2. And so what do you get from this? You get 2 to be equal to a, and here you will have minus 2c. So from this, minus 2c will be equal to what? Taking this a to the other side, you will have 2 minus a. So minus 2c will be equal to 2 minus a, which is 2 minus 4 by 5. So the LCM is 5. Okay, because a, the value of a is 4 by 5. That I have substituted over here. So LCM is 5. So 5 2 times is 10. 10 minus 4 is 6. And so you will have 6 by 5. And from this c will be equal to, taking this minus 2 to the right, you will be having 6 divided by minus 2 multiplied with 5. So 2 1 times, 2 3 times, and so you will have the value of c to be equal to minus 3 by 5. So we have obtained the value of c. So patiently go through these steps, you will definitely understand it better. And then we have evaluated the value of a and c. Now we have to find the value of b. But for that, we cannot make substitution for s in order to make a and c as 0. So for that reason, we are going to compare the coefficients on left hand side and right hand side. What are the coefficients that we are going to compare? Now if you see in this term, if you multiply bs with s, you will be having bs square, and there will be no s square terms other than that. So here you will have a bs square term, and here when you multiply a with s, you will have an as square term. So we are going to compare the coefficients of s square alone on left hand side and right hand side as well. So on the left, do you have an s square? No, we don't have an s square, which means the coefficient of s square is 0 over there. So on the left, coefficient of s square is 0. So let me first write what we are doing. So comparing the coefficient of s square on both the sides. On the left side, we do not have an s square term, which means its coefficient is 0, is equal to, on the right, there are only two s square terms. So as square you will have and bs square you will have. So only two terms. What are the coefficients of s square on the right? Here you have a, and here you have b, and we have a plus sign over here. So we need not expand fully. We can do it mentally also. So here you have a plus. So therefore the right hand side will be a plus b. So from this already we have the value of a. So from this b will be equal to minus a. But what is a? A is 4 by 5. So therefore b will be equal to minus 4 by 5. So we have evaluated the value of b also. So now we have the value of a, b and c as well. So we can substitute these three values in equation 1. So on substituting, what do we get is, the left hand side remains as it is. So we will write the left hand side first. So I have written the left hand side as it is. Now we have to substitute the value of a over here. A, what did we get? The value of a is 4 by 5. So if we substitute that, we will be getting 4 divided by 5 divided by s minus 2 plus, what is the value of b? B is, here we have minus 4 by 5, and the value of c is minus 3 by 5. These two values we will substitute. So here we will be having minus 4 by 5 multiplied with s plus minus 3 by 5, the whole divided by s square plus 1. So this is what we get. Now let us take inverse Laplace transform on both the sides. So on the left we have taken the inverse Laplace transform. So we have the inverse Laplace transform of this term, and that is equal to the inverse Laplace transform of the first term. 4 by 5 is a constant. So let us write that out. And inverse Laplace transform of 1 by s minus 2. And then for the second term, we have two different terms which can be separated and can be written. The first term is minus 4 by 5 is a constant. Laplace inverse of the first term is s by s squared plus 1. So s by s squared plus 1. So I have written the first term. What is the second term? We have a minus and then 3 by 5. Laplace inverse of, now here we have 1 only because we have taken this 3 by 5 out. So 1 by s squared plus 1. So this is what we get. Now we shall use the inverse Laplace transform formula for each of the terms and apply over here. So these are the formulas that we are going to use here. So already we have seen this formula. So let us substitute each of them now. So therefore the given question will be equal to, what is the first term? 4 by 5. Inverse Laplace transform of 1 by s minus 2. So we should use this formula where the value of a is what? 2. So when we apply that, we will have e to the power 2t. The value of a is 2, and so e to the power 2t. So 4 by 5, you will get 4 by 5 e to the power 2t. And now we will come to the second term. The second term is minus 4 by 5. So let me write that. So minus 4 by 5. And we have inverse Laplace transform of s by s squared plus 1. Which is same as this, s by s squared plus a squared. A squared is 1. 1 can be written as 1 square. So instead of a, we are having 1. So in this formula, at the place of a, we have to use 1. So it will be cos at, so cos 1t, which is cos t. So therefore we will have cos t. And the last term is minus 3 by 5. So let me write that. So minus 3 by 5. And then what you have? Inverse Laplace transform of 1 by s squared plus 1, which can be written as a by s squared plus a squared, where the value of a will be what? 1. Because of that only we have 1 here, and here we have 1, which can be imagined as 1 square. And apply this formula. So we get sin at, the value of a is what? 1. So we will have sin t. So therefore this will be sin t. So therefore we have obtained the required answer. So hope you have understood how to evaluate the inverse Laplace transform by using partial fractions. Kindly follow the next video lecture for problem 4 under this topic. Thank you.